This is the Math 3 Unit 10 Worksheet 6. I'm going to go over a few problems here. Number 1 through 12 asks us to convert each angle from degrees to radian measure or from radians to degrees, whichever is appropriate. Something that's helpful in the conversion process is to know that pi radians is equal to 180 degrees. And so here we're converting each angle from degrees to radians. Number 1, we have 135 degrees. And what I'm going to do is I'm going to set up a proportion, degrees over radians. So I have 135 degrees. I want to convert that to radians. And I know that 180 degrees is equal to pi radians. And so here's a proportion we can use to solve for x. And so we cross multiply and we get pi times x is equal to 135 times 180. I'm not multiplying correctly here. Let me fix that. 180 times x is equal to 135 pi. Divide by 180 and you get x is 135 pi divided by 180. And then we can look to reduce this fraction. If we divide top and bottom fraction by 45, we end up with 3 pi over 4 radians. Number 3, here we have a radian measure, 7 pi over 5, and we want to convert to degrees. We could set up a proportion, but here if we're going from radians to degrees and we know that pi is 180, we could just substitute in 180 for pi and then simplify. 180 divided by 5 is 36, so this is 7 times 36. And 7 times 36 is 252 degrees. Number 5, we have 330 degrees. We want to convert that to radians. We know that 180 degrees is going to equal pi radians. And so if I cross multiply here, I get 180x is 330 pi. Divide by divide by 180 and you get x is 330 pi over 180. We can divide top and bottom by 30 and we get 11 pi over 6. Number 7, we're in radian form. We're going to convert to degrees by substituting in 180 for pi. And 15 times 180 divided by 8 comes out, well, it doesn't work out evenly. We can reduce a little bit, so let's do 15 times 180. We get 2700 over 8, and if you divide that by 4, you end up with 675 over 2 degrees. Let's look at the next set of problems, 13 to 24. We're asked to sketch the reference angle for each of in the correct quadrant, and then find the sine, cosine, and tangent of each angle. And so to do this, we're looking at 5 pi over 4. Here's 0 radians. We're moving counterclockwise around, and here's pi radians. and I'm working with 5 pi over 4, which is a fraction. And so I'm going to change pi to 4 pi over 4, which is an equivalent fraction, just with a common denominator. If we keep going around, at 0 degrees we get 2 pi, but 2 pi is equivalent to 8 pi over 4. And 5 pi over 4 is between 4 pi over 4 and 8 pi over 4, so it's going to be in quadrant 3. Here's our reference angle, and our reference angle is going to be the difference between 5 pi over 4 and 4 pi over 4. So if you subtract those, theta prime, or our reference angle, is going to be pi over 4. Well, at this point, our reference angles that we can work with are 30, 60, or 45 degrees. And remember, pi is 180, so if we convert this to degrees, we get 180 over 4, which is 45 degrees. And so this is a 45, 45, 90. We use our side lengths that we want to work with, make our two shorter sides length 1 and our hypotenuse root 2. And so the sine, well, also let's respect our quadrant we're in. Both the x and y values will be negative. And so the sine is negative 1 over root 2. The cosine is negative 1 over root 2. And the tangent is negative 1 over negative 1. Using SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Each of these can be simplified. On the first one, we don't want root 2 in the denominator, so we multiply top and bottom by root 2 and get negative root 2 over 2. Same thing happens for the cosine. And the tangent simplifies to just 1. For number 15, 5 pi over 6. Again, this is 0, moving counterclockwise. This is going to be pi, or pi is 180 degrees, but pi is 6 pi over 6, or equivalent to it. So 5 pi over 6 is going to be in quadrant 2, which tells us our reference angle is the difference between them. So if I subtract 5 pi over 6 from 6 pi over 6, I get pi over 6. Pi is 180, so if we convert this to degrees, we get 180 over 6, which is 30 degrees. So we have our 30, 60, 90 right triangle. I'm going to use opposite side length 1, hypotenuse length 2, opposite 60 is root 3, and then respect the quadrant by making the x value negative. So the sine of this angle, theta, 5 pi over 6, is going to be opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. Again, we got to rationalize our denominator for the tangent, so we multiply top and bottom by root 3 and get negative root 3 over 3. Here's 0, pi, or 180, which I'm going to make it 3 pi over 3 to get a common denominator. 5 pi over 3 is going to be past that. Well, 2 pi is a full 360, and 2 pi is equivalent to 6 pi over 3. And so 5 pi over 3 is closer to 6 pi over 3 than 3 pi over 3, so it's going to be in quadrant 4. The reference angle is the difference between 6 pi and 5 pi over 3, which is pi over 3. Convert that to degrees, we get 180 over 3, which is 60 degrees. So 60 degrees is what we're working with. And so I'm going to make opposite root 3, negative root 3, respect the quadrant. This is positive 1, hypotenuse I'm going to make positive 2. And so the sine of theta is going to be opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent, which is just negative root 3. Negative pi over 6, this is 0. Going this way, this is negative 6 pi over 6, which is negative pi, or negative 180. So negative pi over 6 is just in quadrant 4. And the reference angle is going to be the difference between 0 and pi over 6, which is pi over 6, which is 180 over 6, or 30 degrees. So we got a 30, 60, 90. Opposite side length, I'm going to make negative 1 respecting the fourth quadrant. This is root 3. This is 2. So the sine of 30 is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. When we rationalize the denominator by multiplying top and bottom by root 3, we end up with negative root 3 over 3. Skip to the next set of problems. Take a look at 25 to 30. Here we're to sketch each angle and find the sine, cosine, and tangent. It seems it's the same instructions as before, but these angles are going to be quadrantal, which means they're going to land on either the x or the y-axis. So we got 0 degrees. We have pi right here, back to 2 pi. But this is over 2, so this is 2 pi over 2. This is 4 pi over 2. So 3 pi over 2 is right in between 2 pi over 2 and 4 pi over 2. So it's pointed straight down at 270 degrees. So this is 3 pi over 2. It's not in any quadrant. It's right in between. So when that happens, we're not thinking reference angles. We're not thinking triangles. We're thinking the unit circle, which is a circle with center 0, 0 and a radius of 1. And we're looking for the coordinate of that point at that location, which is not too hard to get. You're just going 1 unit below 0, 0, which is at 0, negative 1. And so in this context, the sine is equal to your y coordinate, which is negative 1. The cosine is equal to your x coordinate, which is 0. And the tangent is equal to the y divided by the x. But we can't divide by 0, so we say undefined. We got 5 pi over 2. It's helpful to, with some of these, to realize that pi over 2 is 180 over 2 in terms of degrees, so it's 90 degrees. And so if I think of 5 pi over 2, you can think of that as 5 times pi over 2, or 5 90 degrees. So as you count this, you have 0, you have 1 pi over 2, you have 2 pi over 2, 3 pi over 2, 4 pi over 2, back at 0, 5 pi over 2. So 5 pi over 2 is the same location as pi over 2. It's on the x-axis. So we're going to use the unit circle looking for that coordinate. So it's 1 unit above, or distance of 1 above 0, 0, which is at 0, 1. So the sine is your y coordinate, which is 1. Cosine is the x, which is 0. And the tangent is y divided by x, which is 1 over 0. We can't divide by 0, so it's undefined. (28) is 4 pi. So remember, pi is 180, so if we count by pi, we go 180 each time. So here's 0, 180 degrees is pi. Count 2 pi, go again, 3 pi, Go again. 4 pi. So 4 pi is at the same location as 2 pi and 0. So we say all three of those are coterminal. And we're looking for the coordinate on the unit circle located at that position, which is just one unit to the right of 0, 0, or the coordinate 1, 0. Once you have that, the sine is your y coordinate, the cosine is your x coordinate, and the tangent is y over x, which is 0 over 1, which is equal to 0. Let's look at the next set of problems. 31 to 34, you're to find the ordered pair on the unit circle for each angle. So 3 pi over 4, if we think about where that is, here's 0, here's pi, which is 4 pi over 4. So 3 pi over 4 is located in quadrant 2. And we're looking for the x and y coordinate of that point. What we do know is this is part of the unit circle, so the radius of that circle is 1. And we know that the height here is our y coordinate, and the base here is our x coordinate. Also keep in mind that x has got to be negative, y has got to be positive because we're in quadrant 2. The reference angle here is the difference between 3 pi over 4 and 4 pi over 4, which is pi over 4. And convert that to degrees and you get 45. So this is a 45, 45, 90. But it's not the one we typically use, because ours, I'll draw the one we use. We usually put 1, 1, and root 2. So this one's a little different because we have to work within the unit circle and have a hypotenuse or radius of 1. And so these two triangles are similar, and so we can move from one to the other. If I take my three values, the root 2, the 1, and the 1, well, here's one way to do it that might be more straightforward. Set up a proportion. So if I want my y value, I'm going to say y over 1 is equal to 1 over root 2. And here's where this is coming from. So if we take the 1 and the root 2 from the second triangle and the y and the 1 from the first triangle, those are, we're working with the opposite over hypotenuse. The first triangle is equal to the opposite over the hypotenuse of the second triangle. And you could just cross multiply, and you get root 2 times y is equal to 1. And so y is equal to 1 over root 2, or root 2 over 2. So root 2 over 2 is our y value. And it's got to be positive. And we can do the same thing for the x value. When you do, you're going to get the same kind of proportion. You're going to get x over 1 is equal to 1 over root 2 again. And you're going to end up with the same answer. The only thing you got to be careful here is, remember, x should be negative because we're working in quadrant 2. So that's one way to go about this. Another way to go about this is to just divide each piece by root 2. Scale it down to the first triangle. You'll get that answer. A third way is to remember that on the unit circle, the x value is the cosine of 45, and the y value is the sine of 45. And I'll use that method on the next one. So for 33, 5 pi over 3. If we think about where that is, here's 0. Move this way, we have pi. And we're working with the denominator of 3, so I'm going to use 3 pi over 3. And then keep moving around. This is 2 pi, but 2 pi is the same thing as 6 pi over 3. And 5 pi over 3 is closer to 6 pi over 3 than it is to 3 pi over 3. So we know we're in quadrant 4, and that's what's drawn here. So again, this is our reference angle. This is pointed at 5 pi over 3 here. And the difference between 6 pi over 3 and 5 pi over 3 is our reference angle, which is pi over 3. You just subtract them. And if you convert that to degrees, you get 60 degrees. And we're looking for x and y. So 60 degrees, I'm going to draw our 30, 60, 90 right triangle with side length 1, opposite 30, this is root 3, this is 2. That's the triangle we'd like to use here. In quadrant 4 though, remember this y value will be negative. And remember, x is the cosine of our angle. So the cosine is adjacent to 60, 1 over the hypotenuse, so 1/2. So we have our x value. Our y value is the sine of our angle. Sine is opposite over hypotenuse, so negative root 3 over 2. And so now we found our coordinate. X is 1/2, y is negative root 3 over 2. So there's a second way we can approach this. In 31, I went about using similar triangles. In 33, I used the idea that your x is your cosine of theta, your y is your sine of theta. Both methods work. Pick the one that you like. 35, last one here. Here we know that tangent of A is 5/2. So here's angle A, and we can only talk about tangent if we're working with an if we're working with a right triangle. So I'm going to draw the altitude. And if I draw the altitude, we know this is 90 degrees here. It makes a right triangle. And we could show that the left triangle and the right triangle, that we make the two smaller triangles by dividing them in two. We can show that they're congruent by using hypotenuse leg. And because they're congruent, we can argue that this 8 feet gets split into 4 and 4. So tangent, we know tangent is opposite over hypotenuse. I'm going to call this side length x. And I know that the tangent of A from my picture is going to be x over 4. But the problem itself tells me that that's equal to 5 over 2. And so I have a proportion I can cross multiply and get 2x is 20, and so x is 10. And now I have the height of this triangle. That's nice because that gives me the area of a triangle, remember, is 1/2 base times height, which comes out to 40 square units. Now for the perimeter, we're going to have to know what the hypotenuse is. I'm going to call that length h for hypotenuse. And, well, we have we can use Pythagorean theorem. 4 squared plus 10 squared is equal to our hypotenuse squared. So this is 116. So our hypotenuse is the square root of 116. If we break down the number 116, 116 is going to be divisible by 4. It's 29 times 4. 4 is 2 times 2. And so we have a perfect square as one of the factors. And so we can simplify this to 2 root 29. Because it's isosceles, we also get the right side. So our perimeter is the sum of the three sides of the triangle. 8 plus 2 root 29 plus another 2 root 29. Well, we have two terms that have root 29, so we can add those together, and we get 8 plus 4 root 29. And then no matter how tempting it is, don't add the 8 and the 4. This is as far as we can go without a calculator, because the order of operations tells us we would have to multiply the 4 times the root 29 before we can add the 8.